Okay, in this lecture, I'm just going to essentially sum up everything that we've done so far in the course and just make sure that we're all on the same page. So first of all, what are we doing here? We are in statistics, a statistics course, which statistics is in and of itself, it's a discipline that focuses on the collection, organization, analysis, interpretation, and presentation of data. And so remember at the beginning of the semester, we showed you this picture of all these Legos that are all just mixed up and it's just a big mess. And so what we're doing is we're organizing it all in such a way that it's like, hey, red, yellow, green, blue. But instead of doing that, it's like, okay, we've got data that's qualitative. We've got data that's quantitative. We've got data that's nominal, ordinal, interval, ratio. And depending on what type of data you have, you can do different stuff with it. And so that's really what we're doing in this first unit. It's saying, hey, what are the different types of data that we have? And how is that impacting what we can do with that data? How is it impacting how we can organize it, how we can analyze it, how we can interpret it, how we can present it? And that's why in the Unit 1 formula sheet, I give you everything that you need in order to be able to say, hey, we've got this Unit 1 formula sheet, and I'll go ahead and pull this up. Let me share my screen. Got the Unit 1 formula sheet, which I'm going to pull up. And so we've got QBA 2302. We'll go down to resources. And we're going to go to Unit 1 formula sheet. Okay. And so right here, it's like, okay, we've got qualitative, we've got quantitative, we've got nominal, ordinal, interval, ratio. And then it says, this is what you can do with it. Just like with Legos, it's you break it all up. You say, okay, we've got, Lego Technics. You can only do certain things with Lego Technics. We've got normal bricks. You can only do certain things with normal bricks. So depending on the type of data that you have, you can do different things with it. Okay, so now we've got this wonderful information of what different types of data that you have and what you can do with it. Okay, so starting with nominal data, we have different types of data. Nominal data is like, for instance, we've got all of this data right here in your workbook. And if you want to take a minute to just go ahead and open up your workbook, we'll just kind of go through this and kind of go through, hey, what's nominal, what's ordinal, what's interval. Nominal data really is not very beneficial for a lot of things because all that you can do is sort it into, showing that there is a difference. So let's see here. Right here, we've got nominal data. Because all that we can do is we can sort it because Chick-fil-A is different than Chipotle, is different than In-N-Out Burger, is different than McDonald's, is different than Raising Cane's, is different than Subway, so on and so forth, going all the way down. Because all that you can do is say they're different. Same thing here. This is also nominal. You can sort it and you can be like, okay, they're just different. This one, however, we can sort it a little bit differently, which I don't know necessarily how to sort it in this, but extremely likely, the next thing should be moderately likely, then moderate or slightly likely, and then so on and so forth. But these are not in order just by me putting them in alphabetical order. So this one right here would be ordinal. Okay. Oops. And then same thing with this. This would also be ordinal, 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 because when I try to sort them, they have an actual order that they can go in. Now, this going a little bit further, not only can you say that they have an actual order of smallest to largest, but you can say, okay, how much do they differ? So it differs like between 50 degrees and 56. It differs by, 6 degrees. So on and so forth. And so the big question here is, you can see that there's an actual numeric value. And so we're going to put, it's either going to be, well, it's going to be quantitative, which means that it's either going to be interval or ratio. The question that we have here is there a meaningful zero? And if there's not a meaningful zero, then it's going to be interval. And so 0 for temperature just means 0. And you guys might be looking outside right now, who knows? And it might be 0 degrees. Actually, probably not in Texas, but I think it's like 22 right now. So same thing with year. 0 does not actually mean anything. They are real numbers, but 0 does not mean anything. Okay, and then how much would you spend on a meal? So this one right here is ratio, because if you spend 0, that means that you did not spend anything. Okay, and time willing to travel, this is also 0, or this is also ratio, because yeah. So that's a quick overview of that. Let's see, college. This once again would be nominal. This would be ordinal. This would be dichotomous. This would be, once again, interval. Then this would be nominal. They're just different. And then this one right here would be ratio. Okay. So moving on, when we display data, it's really important to know what you can use to display the data. So if you have qualitative data, so in other words, let's go back to this. Which ones are qualitative? All of these. These are all qualitative. These are quantitative, and I really hate, so qualitative, I don't like that color. Okay, and then more qualitative. And qualitative. So for the ones that are in yellow, you should really only use like a pie chart or a bar chart. And once again, in this fun little formula sheet, it tells you what should you use for nominal and ordinal. You should do frequency table, pie chart, bar chart. Okay. And so once again, this is telling you, you've got a certain type of data, what can you do with it, or what should you do with it? And then with these, you can do a histogram, you can do a box and whisker, you can do a frequency polygon. And so you have a lot more options when you have quantitative data. Okay. And there's a lot more graphs too that you could possibly do. So displaying qualitative data. Now in Excel, a little bit harder. Let's look at this really quick. Insert pie chart, and you'll notice it does not allow you to just highlight and do insert pie chart. So instead of that, what we're going to do is we're going to do insert pivot table, and I'm going to just put it in a brand new thing. So insert pivot table, and I'm going to do chicken likelihood to purchase. How likely are you to purchase chicken? I guess I need to fix something really quick. So let's do insert pivot table, and instead of A2, we're going to do A3. There we go. So now let's do values. And now that we have this into, this is referred to as a frequency table. Now that we have this in a frequency table, because it says count, we're able to insert pie chart. Okay. And I would encourage you to sort these, sort largest to smallest. Okay, and then the other really important thing is it needs to have percentages in here, because we're always talking about the parts of the whole. You could also do a bar chart. So insert bar chart. And so you've got Chick-fil-A, so on and so forth, going all the way down. And so these are the actual frequencies. This is for relative frequency. So let's click on, let's see. So yeah, and then clicking on this, and you can say, okay, I want it to be percentages, not values. Okay. And so that's appropriate for qualitative data. And everything should be accounted for when you're presenting qualitative data. I would do these once again. If your purpose is to determine the parts of the whole, you should do this. If the purpose is to compare the frequencies, you should do this one. Now, a relative frequency distribution. So say I come in here and I want to pivot table. Let's see here. I want to make a relative frequency distribution. Then you'd come right here, and instead of count, show values as percent of the grand total. Now this right here makes it into a relative frequency distribution. It's the same thing as if you were to do equals 102 divided by 221, okay? Equals 34 divided by the total, and so on and so forth, going all the way down, okay? So that's a relative frequency distribution, and that is all showing up right there. And notice when I did that, it jacked all this up right there too. So just ignore that. And I'll delete this. Okay. Next, with quantitative data. You know, if we have data that's quantitative, so let's go ahead and look at the data that we have that's quantitative. And we will specifically do, let's see here, expected food cost. Yeah, I like expected. Amount that we spend on books. Let's do expected food cost. So we're going to do the same thing-ish. We're going to do insert, pivot table. And we are going to do table range A3. Okay. And then new workbook. And then we're going to do, what is your expected, how much do you expect to spend on a meal? And there's a big problem here. Food cost. This is a sum. Okay, so this is the sum. So instead of the sum, we're going to summarize values by count. So cost or meal cost. Okay, now how many total observations are there? That's a great question. Let's go back to the original data and we'll find out how many total observations there are. Okay, there are a total of, let's see here, about 221 observations. There are a few blanks. So, you know, that looks like maybe 218 observations. So 218 observations. Step one that you need to do is you need to determine the number of classes. So there's, yeah, 218 observations. Whoops, that would have been easy enough. 218 observations. And so in order to determine the number of classes, the very first thing that we need to do is the 2 raised to the k is greater than n. Okay, so 2 raised to the what is greater than 218. And so we're going to do first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. And so we're going to do equals 2 raised to the whatever. Okay, and we're going to find the first one that goes over 218. First one is 8. So this tells us that we should probably have about 8 classes. So what we're going to do is we're going to group this data together. Okay, so we're going to group starting at 3, ending at 15, and going by 1. Well, how many is that? That right there is 12 classes. So we could do that. We could also do starting at 3, you know, doing it by 2. So what does that do? That gives us 6 classes. So we could either have 6 classes, or if let's move this out of the way. Group by 1. So this gives us, let's see, 3, 4. Yeah, so this gives us a total of 11 classes. So that's more than the 8. And so, the other option would be like, oh, let's do like a 1.5. Really what you should do is you should do the range, which is going to be equals 15 minus 3. Okay, so that's going to be 12. So equals 12 divided by 8. So this should be the range, and so it's 1.5. So let's see what would it look like if we did 1.5. So group 1.5, and now this is exactly what it's supposed to be. The question is do you really want to have it like this? And to be completely honest, I'm not entirely opposed to this. There's nothing wrong with it. Let's see here, insert. And another thing is when you do this, this should be a histogram. So I'm gonna click on this. Let's see, click, and gap width is going to be 0. And so now we have a histogram, but it would change if, let's see here, group by 1. Okay, 1 looks a little weird. Let's do group by 2. Okay, and so I actually think that a 1.5 or a 2 is probably the most appropriate. And so when we look at this, we're able to say, okay, we've got a histogram for 1.5 or so on and so forth, a histogram for this information with a width of 1.5. Okay, and so let's see here. Group 1.5. And it looks pretty good. It shows, hey, there is that 12 to 13.5. There is a little bit more in that group as compared to, around it. So that's a histogram, and then a frequency polygon is very similar. You do insert frequency polygon, and all that it does, let's make this transparent. No fill. Okay, so you'll see right here, I'm going to put these right over the top. And what it does is it goes to the midpoint. There we go. And then, so you'll see it goes to the midpoint of each one when you do a frequency polygon. Next, let's do the same exact data, except let's do it with a box and whisker. Okay, so I want to do a box and whisker plot of this data. Let's see, where is the data? So I've got this data right here of expected meal cost. Actually, instead of this, I'm actually going to do amount spent on books, because we're going to get some bad data with this, and I want to get some bad data so you can see what it'll look like. Okay, so how much money do you expect to spend on books? So I just copied and pasted all that in here. And so this can only be done with quantitative data. So now I'm going to do, hey, give me a box and whisker. Okay, right away, we've got this box and whisker plot. And what this tells us is that we have a minimum value that is not an outlier of 0. And then we have a mean coming right here, which I'm going to go ahead and add chart elements, data labels to the left. So we've got a mean of $375.69. We've got a median of 300. We've got Q1 is 200, Q3 is 500, and then we've got the max value that is not an outlier is 900. And then you'll notice that we have like 3 values above this, 980, 1000, and 2000, that are all outliers. And so the way that we calculate the Q3 or any of the quartiles, we can do this by hand as well, especially if you have a less number of observations. And the way that you do this is n plus 1 multiplied by the percentile that you're looking for divided by 100. Okay, or the quartile that you're looking for divided by 4. So if we are looking at n plus 1, and mind you, this only gives you the position. Okay, so you've got to sort all of these from smallest to largest. So let's do smallest to largest. And let's find out how many observations we have. We have a total of 221 observations. Okay, so 221 plus 1, okay, equals 221 plus 1. And then if we want Q1, so equals multiplied by 25 divided by 100. So this gives you the location of Q1. Okay. So the location of Q1, the whole reason why we're doing this is we want to be able to make more sense out of the information that we have. Because in other words, we can say that 25% of observations fall below whatever the value is that corresponds with Q1. So let's go here and we're going to do, we're going to find 55. So what we have here is 25% of the data. This right here is 25% of the data. Actually, I'm going to do this a different way. And the reason why I'm going to do this a different way, sort, okay, is because I want to show you 55. This right here is 25% of the data. Okay. And then, so 25% of the data falls below 55.5. So it's the average between these two. And then let's see here. We need to do location of Q3. So location of Q3 is going to be equals 222 multiplied by 75 divided by 100. So it's 166.5. So we're going to go back to our data and do 166.5. Find 166.5. So 167. So all of these. And then, so now what we have is 25% of the data is right here. 25% of the data is right here. And then 50% of the data, otherwise known as the interquartile range between Q1 and Q3, is right there. So let's find the median really quick. Median is going to be the exact same thing, except we are going to do 50 over 100. And so that's going to be 111. So we're going to come right here. And we're going to find 111. So 111, this right here, we'll make this blue. And then we'll do this one in and of itself will be, I don't know, orange. And the question is does this belong in Q1 or sorry, does this belong in Q2 or Q3? And the answer to that question is really neither. You're just at the 50th percentile. And so if you, I'm not going to give you anything that really makes you have to decide that. Percentiles are really much more for understanding the population than they are trying to give you statistics about a single sample. And so that's why we've got, you know, Q4 is up here. This is Q3. This is Q2. This is Q1. And so now we've got it broken up into four spots. And we're also going to make this, let's see here, insert box and whisker. And you'll notice, let's see here. like I won't be able to make it do what it is that I want it to do. But you'll notice that, you know, this right here is the smallest. So Q2 is has the smallest range. The Q1 has a pretty large range. Q3 has a pretty large range, and Q4 has the largest range. And then these are the outliers above Q4. And it's important to note also that just because you have outliers, you know, there could be multiple outliers up here besides just those two. These are all, if I'm not mistaken, let's see here, what is considered an outlier. Yes, so let's do the outlier limit. So the outlier limit, the way that you calculate the limit of what is an outlier is you do 1.5 multiplied by the IQR, okay, plus Q3, okay, and then you can do the same exact thing for the lower, except you're doing Q1 minus 1.5 multiplied by the IQR. Okay. So Q1 minus, and then Q3 plus. And so the interquartile range is going to be the value of Q3 minus the value of Q2. So let's find the value of Q3. So the value of Q3 is going to be 500. And the value of Q2, or sorry, the value of Q1 is going to be 200. So it's going to be 500 minus 200. So that's 300. So the actual value, 200, 500. And then what was just for 300 was, okay. So we've got an interquartile range of 500 equals 500 minus 300, or sorry, minus 200, which is 300. And then we're going to do equals 1.5 multiplied by 300, which is 450. And so we're going to add this to that 500. So anything above 950 is going to be an outlier. Anything above 950 is going to be an outlier. So all of these right here are outliers. So notice right here, you only see 1, 2, and 3. The reason why is because these thousands are all right on the same thing. So it's important to note that we actually have, let's see here, 8 outliers. Okay, they're still accounted for. You still use them when you calculate everything else. And once again, the whole purpose of this is all that we're doing is we're describing the data. We're using a visualization, we're using a chart to be able to make sense out of this data. And when we can read this chart and say, okay, 25% is in there, 25% is in there, 25% is in there, we can organize it and really make sure that we thoroughly understand it. Okay, let's see here. I'm going to go to this right here. So we've did nominal. We're not really doing stem and leaf, but you are doing a box plot. There's a whole video on scatter plots as well. And then the mode, median, range. So I'm going to go over variance and standard deviation in class, but skewness. I want to talk about skewness. Skewness is when data is not necessarily perfectly symmetrical, like this right here. Data is perfectly symmetrical, going, you know, that nice pretty thing. And when you have skewed data, it looks here. Let's Google skewed data images. And so you've got data that's positively skewed, negatively skewed, or they're symmetrical. The rule of thumb is when the mean is greater than the median, it's positively skewed. So you can literally look at this chart right here, and you can see the mean is greater than the median, so it's positively skewed. When the mean is greater than the median, it's positively skewed. And then also when the mean is less than the median, it is negatively skewed. Now, the degree to which it's skewed will vary, but like this right here, I can tell you that this is pretty positively, or probably fairly positively skewed, not extremely, but the reason why it's positively skewed is because of all these outliers. And the reason why we care is when you have data that's more skewed, it's difficult to run statistical analyses on data that is that's skewed. So that's why we care about that. So skewness is basically talking about the shape of the data. It's saying, is it negatively skewed where you have outliers going towards the negative side? Or is it positively skewed where you tend to have like a few more outliers or a dispersion that is pulling it, towards the positive, pulling the mean towards the positive. And once again, all that we're doing is doing our best to be able to describe the data that we currently have. We're describing the data over and over again. Okay. Let's see here. There are Excel formulas for everything. And so there's this fun little sheet right here that shows you how to get all the Excel formulas. And let's see here. Mean, median, mode, quartiles, and then this right here, you calculated the mean, median, mode, and the sample standard deviation, and all of this we're going to be going over in class. But up until this point, all that we've done really is just done what we can with describing the data that we have, showing how it's broken up by percentiles, quartiles, so on and so forth, nominal, ordinal, interval ratio, being able to describe things, being able to look at a frequency polygon and say, okay, look at this frequency polygon, I understand what it says. Looking at a histogram, knowing what it says, so on and so forth. Okay, so that should catch you up for the most part. Another thing that I want to show you really quick that I highly suggest that you do is going in here. Okay, continuous variable can assume any value within a specific range. So what I'd suggest is you just come through here and give an example. So continuous data, temper in Texas can range anywhere from 15 degrees to 80 degrees in a single day. And it's that is continuous data, which is temperature. Okay, discrete variable can assume only certain values. There are gaps between the values. Okay, so discrete, you put an example of discrete. Discrete is essentially saying, they are separate. So let's see, what do I have that's separate? I have this super cool Nerf gun, and I have one bullet. Nerf 2. So the number of Nerf darts that I have for a Nerf gun, because 1, 2, and they are discrete counts, and I actually have a total of 6 in this Nerf gun, and then I have another 3 in this Nerf gun. So now I have a total of 8 darts, and so you could put, I have 8 darts for my Nerf gun. You can't have half a dart. I suppose you could. You would cut it in half, but it essentially becomes useless. So I have 8 darts for my Nerf gun. Okay. Qualitative variable. Just put an example of a qualitative variable. There are 7 different colors of highlighters on my desk. Okay. quantitative when a variable can be reported. And so just going through this over and over, like all the way down, I'd suggest you guys get with your group and just help one another out going through this. And this will really help you to practice for the, this will really help you to practice for the exam. Other than that, I think that's all I got. I hope that this helped to bring everything together. Like I said, all that we're really doing right now is just describing data and saying, hey, this is what it is that we're doing. And yeah.